So when you start the simulation file, you start off with this page here, and you've seen that we've already designed some of these elements, the mem_1, mem_8, the enable, the register, and we've seen how the decoder is designed. So let's have a quick look and see that these are the same elements that we have actually designed. So you can see here that the 1-bit memory, well, it's the same. The 8-bit memory, it's the same as well. But now when you come into this enable section, you see it's very similar, but you've got all these extra added gates here. Now these gates are called control buffers, and that's what we're going to talk about in this video. Let's have a look at this circuit here. So let's imagine we had a bus, so that's one bus wire here, and it's connected to two outputs. So there's an output for this AND gate and an output for this AND gate. And let's say the inputs here are coming from, say, input A. So these inputs, these are coming from some other part of the circuit. So you get some complicated part of the circuit feeding in, eventually going to an AND gate and then onto a bus. And the same for this input here. There's some complicated bit of a circuit heading into this AND gate and onto this bus. Now you'll notice that in this instance here, the bus is red because there's an error here. And you can see where the error occurs, because if this is an AND gate, it means that this is 1 and this is 1. So as far as this AND gate is concerned, there should be a 1 on the output. So this should be going high on the output here. But in this instance here, we've got a 0 and a 1. So it means that in this AND gate here, the output here should be a 0. So it means that the output here is telling the bus to go high, and this output here is telling the bus to go low. So of course the software tool here, Logisim's, looking at this and saying, well, what do you want it? Do you want it to be high or do you want it to be low? And we're not actually telling it, so it doesn't actually know what it's going to be. So it just gives out an error value that says we don't know what the value of this is going to be. It could be 1 or it could be 0. So we need some other way of connecting these outputs, so there's only one of them gets onto the bus at any one time. And now we're going to do that using this control buffer here. So that's a control buffer here, and you'll see these throughout the design. So there's one there, and I'll put another one in here. So these do exactly what they say. They add an extra control, and the buffer, that means they separate the output from here, the output of this AND gate to the input to the bus. So let's go ahead and we'll stick them in just now and we'll see how it's going to work. Right, so that's them in. Now there's also an extra pin here which is going to be a control pin. So there's a control pin for this one and a control pin for this one as well. So at the moment what we'll do is we'll go and stick in a couple of buttons. So there's a button there facing north, and we'll pop in another button for this one. So all the button does is toggle these here. So when you press the button in, it goes high, and then if we let it go, it goes low. Now you'll notice right away, as soon as I went in there and connected that, you'll see that the red wire here is going to change to blue. So right away that's a bit healthier. Okay, it isn't saying that there's an error, it's just saying that the blue means that it doesn't know what the value is actually going to be. Suppose there had been an error value, it's actually saying that there will be a bona fide value there, but it just doesn't know which one it is. It doesn't know which one it is until you actually set this here. So whenever I set, for example, I press this button here, then this enable line here will go high, and it will pass the output from this AND gate onto the bus, so the bus should go high. So you see I've toggled it there and the bus goes high. I'll toggle it again, you see the bus going high. Now if I was to press this one here, then it means that because there's a 0 and 1 here, that will be low, so it should pass that low value, so the output should be low, and there you go. So the control buffer acts like a switch. It physically, you can think of it about it as physically separating this point here from this point here, and it only gets connected whenever the input here at the control point goes high. So this is a perfect way of connecting multiple inputs to multiple outputs, sorry, here to one bus. And you'll see these control buffers throughout the rest of the design, and you'll see that they're connected to the output of registers, and the control line here goes back to the enable, because we're only wanting one register at a time to go onto the bus, and the register that we want to go onto the bus is the one that has had the enable going high. So let's have another look at the enable block. We've seen here that we've got these control buffers on the output, and the way they work is that whenever the enable pin goes high, we want to pass information from a memory location onto the bus. So whenever this goes high, the control buffer control line goes high, and in effect the switch closes and it passes the output from the memory location straight through onto the bus. But of course there's lots of other items here, lots of other parts of the CPU that want access to the bus. So whenever this is sitting at a 0, these control buffers, in effect, they electrically separate this point here from the bus. So it's almost like an open switch. So that's how the control buffers work, and you'll see these control buffers all over the CPU. So everywhere that parts of the CPU that want access to the bus will have to go through a control buffer just like this. So that's all for this video, and I'll get you in the next video. Goodbye.